Alright, so in this video, I'm trying to make a tutorial on how to use the Ti-Nspire calculator to do your binomial probabilities. If you hear a lot of banging in the background, they're working on some things in the background, so I apologize for that. So we're looking at this example that we did in class, and it says a hotel has 4 elevators. One of them is a freight elevator. When pressing the button, one of the elevators randomly services your floor. You're going to use the elevator 7 times. So what we're doing is we're fixing the number of times you can use that. So this becomes a binomial situation. And here we're going to let x equal the freight elevator, right? And because x equals the freight elevator, we know the probability of using that freight elevator. Well, there's 4 elevators, only one. 4 elevators, only one of them is the freight, so that's equal to 0.25. And it told us that our fixed number here, we're going to use that elevator 7 times, so our fixed number is n equals 7. So we've identified that it is a binomial situation. Before we start doing any kind of calculations, we're going to define the parameters using binomial notation. And the notation looks like this. We'll say that x, the freight elevator, follows a binomial distribution, the b, with a n of 7 and a p of 0.25. With this notation now, we can use probability statements to actually write out all of our answers. Because now when I read this, I know that my n is 7 and my p is 0.25, and I know that I can calculate it in my calculator using this one. So it says, what is the probability they use the freight elevator exactly 4 times? So the probability that they use it exactly 4 times. Anytime we see the word exactly when we talk about binomial probabilities, that means we're going to use a binomial PDF. It's a binomial PDF we're going to use. And so we're going to write this as the probability that, remember, we're talking about the freight elevator, exactly means equals to 4. And so if I go to my calculator here, I'm going to first add a calculator with this right here. I'm going to add a calculator here. And the binomial functions are under you press menu, statistics, and your distributions. So 5, 6, the letter A and the letter B are your binomial functions you're going to use. We're going to do the PDF here because it is exactly. And the PDF calls for the number of trials, which are 7, probability of success, 0.25, and how many successes do I want? For this particular problem, I want exactly 4. Calculate that, and we get this value right here, which is 0.058. So when we do exactly, we want to put the exact number there. So we do binom PDF, your n, which was 7, your p, 0.25, and the exact number of successes you wanted was 4. On the next problem, they want to know you use it no more than 4 times. Anytime they say something that is not exactly, anything else that is not exactly, we use what's called the CDF, the cumulative function. No more than 4 means it can be 0, 1, 2, 3, or 4, but it can't be more than that. So we write that as no more than 4 means x less than or equal to 4. And for this, when we use this function, we're going to go menu, statistics, 6 again, distributions, 5. And this time we want to do the CDF, which is letter B. The CDF says how many trials do you, what's your fixed number n? We have 7. Probability of success, 0.25. The difference now is it's going to count from a certain starting point to an ending point. We want to start counting at 0 here and end at 4. We want to count from 0 to 4. It's going to add up everything in there from 0 to 4. So when I do that, I get this equal to 0.987. And again, this is binom CDF. And the CDF says give it a fixed number, probability of success, but this time give it a lower bound. The lower bound is where you're starting at 0. The upper bound is where you're ending at 4. The next one says the probability to choose the freight elevator fewer than 4 times. Well, fewer than 4, how is that different than no more than 4? Well, in a discrete distribution, remember the word discrete means it has to be a whole number. If you're fewer than 4, you're going to be 0, 1, 2, or 3. You can't be 4. So this is just less than 4. We always want to write our notation using less than or equal, though, or greater than or equal in the other case. So in this case, we're going to write this less than 4 is the same thing as probability x is less than or equal to 3. Because again, remember, you're at less than 4 is anything back this way, so that's 0, 1, 2, or 3. When we set this up, then this is another binomial CDF where your n is 7, your p 0.25, Your lower bound, you're counting from 0 again, but this time you're going to stop at 3. So we go here, menu, 6, 5, the letter B this time. And so we do number trials, 7, probability of success, 0.25, lower bound, 0, upper bound, 3. Type it in. And notice how you get a smaller probability because you excluded the value of 4 from this calculation. And the next one, they ask for the probability that X at least 4 times. Well, at least 4, if you look at this table up here, at least 4 would be 4, 5, 6, or 7. So we're going to do greater than or equal to 4 here. And when we do that, again, this is just a binomial CDF, but this time we're going to change the lower and upper bounds of it. So we'll do 7.25, but we're starting our counting at 4, and we're going to add up to 7. And I keep writing these things down here, these binomial things. I'm doing them for you to understand what I'm doing, but I don't ever want you to see it. I want to see them on paper, because this is what we call calculator speak, and this just means that your calculator you're using a specific calculator to do this. Not all calculators set up like a Ti-Nspire. We always want to write these statements over here with the parameter notation over here. So when I go here and do this one, I go menu, statistics, distributions, letters B, number of trials, 7, probability of success, 0.25, lower bound. This time I'm starting my lower bound at 4, at least 4. I'm going to go up to my max in this case, which is 7. Do that. 0.071. And then the last one is a very special case of at least that you're going to see a lot, which is the at least 1 case. And that's the probability that X is greater than or equal to 1. Well, greater than or equal to 1 in any distribution will always be everything other than 0. And we'll learn that eventually this is 1 minus the probability of none. So you can calculate it using that, but because we have our calculators, we can just do binom CDF again. N is 7.25. Our lower bound, at least 1. We're going to start at 1 and go all the way up to 7. So here we go, menu, 6, 5, B, 7.25. Lower bound, you're starting at 1, and you're going to count up to 7. We do that, we get 0.867. And just to show you that the other way works too, we do 1 minus the probability of X being 0. So exactly 0 is what you can calculate that. So we would do menu, 6, 5, and this time exactly means PDF. And I can do it like this, 7.25, and the X is exactly 0, it's here. You calculate that, you get the exact same thing. This is just 1, you're taking it away from the entire sample space, the 0 case. And that also gives you at least 1. So in this case, here's what you're gonna get, either way you do it. I hope this video helps.